G'day team, I'm Matt. I borrowed a camera from work to learn how to use it, so I figured I'd make a video on one of my current carbon projects. It's been a learning experience for me, so maybe you'll pick up something too. As I said, I borrowed this camera from work, so I apologise for the audio quality, the video quality, and also the general lack of professionalism. What you're looking at is the rear wing from a Formula 3 car. Well, at least it used to be, and hopefully it will be again. This wing actually comes from Dallara F304, this one to be exact. Though the wings are the same on the next two generations as well, the 2007 model and the 2011 model, with the profile specified by the rules. This one unfortunately had a bit of a run-in with a wall. I was working for the car owner in a data capacity and offered to repair it for much less than a new one would cost, which was pretty easy seeing as these seem to run for about 10 grand. So we're going to ignore the two upper elements and the end plates and just have a look at the lower wing, also known as the beam wing. It's the most interesting part as it's the major load bearing structure, and also I've cut a hole in it. So this is the beam wing, complete with GoPro mount for recording videos. When we reassembled the car after the shunt, the rear wing wasn't sitting straight. After ruling out the attachment brackets, we identified the culprit as this wing. This is what it looked like when I got my hands on it. When you remove the lower mounting brackets, it looks like this. The more astute of you may notice there's a slight hole there. The mounting bracket sheared through the skin, and there is also some damage either side of where the bracket sits. So this is where it all gets interesting. I assumed the secondary damage was delamination from the core, but then I got a bit of a surprise. So I thought the wing would look like this. It'd be a carbon skin full of foam or honeycomb to create some kind of core, much like a helicopter blade. I also thought there'd be some kind of captive threaded nut sleeve that would be sitting around here to pick up those attachment points. To repair this, I was going to cut away the damaged skin areas. I was then going to cut into the foam to hollow out an area. From there, I'd make a doubler and I'd put that doubler over the cut lines, add a second layer of skin to the whole thing, fill it full of foam, and then work out some kind of way to do the captive nut, probably based on whatever Dallara had done in the wing in the first place. So I cut into the wing to start it all, and then found out that all of my assumptions were completely wrong. Instead of the wing looking like this, as expected, the wing actually ended up looking like this. There was no core material in the wing, it was actually hollow. Instead, there were these shear webs that were picking up the top and bottom layers at both the bolt points, kind of like a I-beam. This kind of screwed my plans. The good news is the attachment points turned out to be much more simple than I expected. Instead of being a complicated specialty fastener, they were simply a block of aluminium with a drill and tap hole in them that picked up both points to maintain alignment and distances. So this is what the actual wing looks like, complete with the custom cuts added by yours truly. Here you can see the outer skin, the inner shear webs, both sides, and also the aluminium block with the threaded and tapped hole. That block goes all the way through to this hole here and picks up this point. If you recall the damage from the previous photos, you may not be surprised that the shear web was also damaged, so it's been cut back a bit in order to facilitate this repair. To fix this wing, I'm going to create a custom shear web to replace the damaged section that picks up from this surface down here and this surface down here, and then sits over this area. From there we'll put a doubler underneath all of these cut sections to provide reinforcement and load path into the new wing skin. We'll then put a wing skin on that'll be thinner than this actual material, and then we'll grind this material back and put a couple of capping layers over, generally in this area here. So first up I have to identify the shape required for the shear web doubler and make a mould for it. To do that I started with a piece of paper and cut it down to size, trying to match it and fit it over the shear web doubler. When I took too much paper away, I added some tape and then I cut into that as well. In the end, I came up with this duva, and it kind of sits on and goes over there like that, and fits in and forms that shear web nicely. I took that cut piece and made up a set of ruled lines like this, stuck it in place on there, and scanned it in using a normal scanner. From there I used a CAD program to take those two lines, stretch the image to the right size, draw around the perimeter of my template, and then make the part. To double check what I had done, I 3D printed out a template and then confirmed the template does in fact fit just like this, so I knew that I was onto a winner. From there I 3D printed a mould of the required wing rib, just like this, and then worked out that I'd done goofed, and then printed another one. The difference between these two moulds is this top section up here and how high or how deep the mould is. You'll see that on the original section that the top part actually lines up perfectly with my check piece, whereas on the reprinted one there's a gap here of about 2.5 millimeters. The reason for the change in the mould was so that the new rib section would sit flush with the original rib section so that we could bond the rib or the wing skin in place. From there I laid up the carbon fibre wing rib using 200 grams per square metre twill for the outside two layers that you can see here, 300 GSM biaxial for the inner layers, and then unidirectional 160 gram per square metre fibres for the inside layers at the top here, and they were only at the top. Total thickness of the top section was about 2.5 millimeters, and then these side bits here were 4 layers of the 200 and the 300, which brings it to about 1.2 mil thick. I then cut it to size, and it fits in the wing rib nicely. Here you can see the replacement rib section cut to size and in location. To make the mould itself, I was super lazy. I love using the 3D printer. It's really simple and makes things, well, I don't have to do any work, but things stick to them. Instead of doing mould prep and sanding and all that kind of jazz, the simplest solution is just to wrap a bit of builder's plastic around it and then mould up over that. Builder's plastic doesn't stick to anything and it gives a pretty good surface and it conforms reasonably well. The inside layer of the rib itself, you'll see here, is actually peel ply, so it has a nice bonding surface, and so is the outside layer. So the stack went builder's plastic, peel ply, carbon, peel ply, breather cloth, and then in a vacuum bag. So far for this repair I've made the following parts: all of the moulding required to make the wing rib itself, the replacement skin, and then the doubler. The replacement skin is about 1.5 millimeters thick, and the doubler is about 3 millimeters thick. All of these have been made using the 2x2 200 grams per square meter twill and the 300 GSM biaxial. To make both the doubler and the new wing skin, I did a similar thing as I did with the mould. I wrapped the original wing in a piece of builder's plastic, laid down peel ply on the underside to give a bonding surface, and then laid the carbon fibre up over the top of that. Instead of bagging this one, all I did was put some more peel ply over the top of it, put some breather cloth over that, and then wrap the whole thing in masking tape to pull it down nice and tight. From here I have to key up the inside of the wing so I can bond the new rib in place. Then I've got to cut the doubler down to size, put it in position, and then put the new wing skin on top of that, before throwing a capping layer over the whole lot to make it nice and smooth and back to being an aerodynamic component. So I walked you through my adventures today for repairing this wing, and I hope you picked something up out of it. If anyone's interested, I'll see if I can steal the camera from work again to show the rest of the build process or one of the other projects I have going on. Thanks for watching.